Welcome to the House of Maths. What I'm looking at today is something called the discriminant. Okay, what is the discriminant and where does it come from? Well, if you remember, or if you've seen my last video, you'll remember that I was looking at the quadratic formula, which I've got written up here. This is the quadratic formula, and the discriminant comes from this. It's actually this little bit here, which I'll write down now. This bit is known as the discriminant, and it's useful for helping us work out how many roots a quadratic has. So think about what a quadratic looks like. Now, your quadratic could look like this. Okay, so this one is going to have two roots. It's going to have a root here and it's going to have a root there. So that's one possibility, isn't it? Two roots. The curve could go like this. Okay, and just touch the x-axis. So it could just have one solution like that, or your curve could be somewhere like that. And there are no solutions. It doesn't cross the x-axis at all. So this helps us to determine which one of these we've got. Now, if this is greater than 0, then we've got two solutions. If this equals 0, we have one solution. Sometimes that's called, you may see it written as repeated roots. It just means it looks like this and it just touches once. It could go the other way around, like so, but there's only going to be one solution. Okay, and finally, if it's less than 0, you've got no solutions. And if you think about it, think about this one here. It's b squared minus 4ac. It's inside, in the quadratic formula, it's inside a root. Okay, so if this is less than 0, you're going to have a negative number in there, say -2, root -2. Well, that's not going to give you an answer if you put it in your calculator. There is no solution to that. Now, I mentioned the word calculator there deliberately. If you use your calculator to solve these quadratics, if you get one like this, your calculator may well give you a solution, and that solution may look something like this. For example, it could be 2 plus or minus could be something like that. Okay, now what that is here is called a complex number, and a complex number has got this bit at the front, which is a real part, and this bit over here, which is an imaginary part. So very briefly, what does that mean? If you take a number line here, 0, 1, 2, all your real parts are going to be on this number line. Now, they could be anywhere on that number line. If it was there, for example, that would be 0.5. If it was right down here, that could be 1.9. So a real number needs to be on the number line. But what happens if you've got something over here? Now, that's not on the number line, is it? So it's not a real number. So what happens is you have another axis. So it looks a little bit like a coordinate grid, but this axis here is I, it's the imaginary part, and this bit here is obviously the positive imaginary bit, and you've got a corresponding bit down here which would be the negative imaginary bit. So if you're using a calculator to work these out, you may well get a solution for this one here, but it will be an imaginary solution, and you won't need that with GCSE maths. You will if you're going on to do A-level maths, but that's what may happen if you use a calculator. Okay, so that's a very brief look at the discriminant. If you like that, please hit the like button, and thanks very much for watching.